Hi, I'm Steve Hinton from the Swedish Sustainable Economy Foundation. You'll find us at tssef.se. I want to talk about systems dynamics, and I want to talk about how to use and apply systems dynamics to looking at how firms impact nature, natural resources, and all kinds of resources. This is to hopefully form a basis for what we might call the circular economy, and I want to work towards creating a decision basis to transition from a non-circular use, which we have now, non-sustainable, to the circular economy. And I will say this is the first time I've done this, and this is really just a draft with a load of ideas. I'm putting this out to get your feedback, so I'm really appreciative of that. So let's just get into this. Now, last time we talked about systems dynamics as being cause and effect diagrams, but you can move away from that by thinking of stocks. So systems dynamics has a stock and a flow view. If you remember, we talk often about the bathtub model of economics, where money flowing into, say, a personal account is like flowing into a bathtub. So then you have a flow in and a flow out. And there are important things, aspects of this stock, and it's, of course, capacity. How much can you hold? I guess people say I can have as much money as I like in my bank account, but there are other aspects of this. If we take, for example, the idea of the circular economy, then you have the idea of a library of materials. We've talked about this in other videos. So you can see, for example, metals as being part of a library. You take them out of the library and use them, and in circularity, you then in some way put them back. You could put them back, for example, just by selling the product on secondhand, or um, recycling components, or indeed taking that metal and putting it back to some form of material status where it can be recycled again. A scrap is a good example. And at this time, we need to think of the thresholds as well. I mean, if you have a stock, then obviously it should not go too low. That would create a problem for society if everyone was scrambling after metals that weren't available. This is also interesting from a point of view of transitioning to everyone using electric cars. I mean, is it possible to have the kind of minerals and metals that are necessary for that? So then we can add this idea that we have parameters that we put onto our flows. That's to say there'll be maybe speeds, volumes, and of course of use. So if you take things out faster than you put them back, then the stock will go down to its threshold. So now, thinking of stocks, an important aspect when you're getting into economy is the idea of capital, real capital, actually. Now, real capital is assets that are utilized in production, in the provision of goods and service, but they're not used up. That's to say, they're used again. So, for example, metals are real capital. Now, the amount of metals that we're losing, that's to say, the ones that are being used in products but not recycled, then that is a degradation of real capital. Now, there are four kinds of real capital, and it's important, I think, for us to identify all of them. Natural capital is the living layer we all rely on. We could also include the layer underneath the living layer, which we could call the lithosphere. From the lithosphere, we get minerals and metals and other substances. And we also can add what's above the living layer underside of it. That's like the climate, water cycle, all the other natural cycles. Now, what we want to aim for as a desired status of our natural capital is working natural cycles, productive and biodiverse forests and other ecosystems, healthy soils, functioning ecosystems, and minerals and metals available to us and future generations. Built capital is the man-made things that we have, and they're used to provide our basic needs. I think are the ones we should concentrate on. This would include houses, roads, factories, equipment, tools, but also systems like our telecoms and our payments, etc. Now, good built capital is the infrastructure that, in a safe, efficient, and comfortable way, provides our housing, our transport, energy, food production, and distribution. And some would say it provides a good health and education services. Now, social capital are our organizations and our institutions, and that includes the knowledge and capability that's in these organizations. So, healthy social capital is ones that would offer gainful and productive employment, but they'd also provide to the social good, and that includes doing this provision in a way that's concomitant with healthy environment and all the other capitals. Finally, we have human capital, and this is what we humans command. For example, in terms of our strength, our knowledge, our insights, our attitudes, our capabilities, our values, everything. Now, good, fully healthy human capital would be healthy, productive, skilled, strong, happy, generous, peace-loving, and balanced people. You can see that anything that that goes on in our productive system to degrade any of these four capitals is something that we need to address. Now, let's go to the production system. Production system is made up of firms, and even say, for example, I mean, this isn't just capitalist way of looking at things. Cooperatives are organized in this way, and even state-run organizations to do this. So let's have a look at a simple model of the firm. It has inputs which it uses, mineral inputs, biological inputs, coming from the left here. At the top, it has the infrastructure. Infrastructure is everything like tools and buildings, all those kind of things. And then labor, it's employees that it employs to produce everything. And then it's the products and services produced for the customer. And then, of course, there's waste that goes to natural recipients. In the end, it might be waste that's sold to another firm. But the whole world seems to be organized in this way, a myriad of firms all buying from and supplying each other. Now, firms are impacting capital. Let's have a look at this. We can look at this directly because a firm is actually part of our social capital. Now, the inputs are natural capital, the mineral natural capital, or the capital coming from ecosystems. The infrastructure is, by definition, built capital. And labor, of course, is human capital. The products and services go to customers, which is human capital, and waste goes to recipients, which is natural capital. So we can start to see how the actual structure of the firm already influences these capitals. Now, why do we focus on infrastructure built capital? So I think we should do, in this discussion of system dynamics, relationship to nature and the firm. Well, the first reason is that infrastructure is the one that requires the most investment. If you think about it, you can sell a product to a customer, and then 30 days later, you can give the money to the employees at the end of the month, say, and you can pay your suppliers for your inputs. However, a firm needs to have its buildings and its tools and its machineries and its computer systems, etc., up and running. So that's the investment that's required up front. That's why that's interesting. Now, the other thing is that infrastructure determines the environmental performance of the firm. If I've gone and bought a fleet of vehicles that runs on diesel and nothing else, then obviously I've invested in an infrastructure that has a poor carbon dioxide performance. The same is true actually of my production apparatus. If it can take, for example, recycled metal and doesn't require mining, and I can just use scrap, and if I can use biological material, maybe biological material instead of minerals, and also the way that the infrastructure performs in terms of creating waste. The ideal infrastructure creates little waste, and the waste it creates can be easily recycled and put back to nature or goes into stock. Now, it also has a social performance, because the capacity of infrastructure is a determiner of how many people the firm can serve with essentials. So it would be one thing if a firm, for example, built a hospital, that would be great. But if it could only serve a small percentage of the population, that would inform our investment decisions. Okay, so let's go back to this production, distribution, and use idea. That let's just say the grey circle is our economy, our producing something, and then we'll draw some lines dotted for recycling and solid for materials. Now, obviously, there's a mineral stock that is used in production, minerals, metals, etc., from lithosphere, and things from the ecosystem. For the mineral stock, it would have to be extracting from reserves. And in terms of the ecosystem, it would be harvesting. In both cases, there is a degradation of natural capital. And notice that that you don't pay for this. This is a free gift from nature that goes into the production system. Now, for this to work in a circular economy, we would need to have a replenishment. That's to say, the mineral stock would come back and be available to the economy, use again. And you'd need to restore the ecosystem, and also that the ecosystem acts as a recipient for waste, if you like. Now, you can start to see that you can add the parameters here, and you can start to see the rate and volumes of harvesting from ecosystem, the rate volumes of extraction from the mineral reserves, how much is going to the recipient, how much is being restored, and how much is being replenished. We can already see now, even in this simple model, that we want our production system to be run in a way that neither the mineral stock is depleted nor the ecosystems are degraded to a point where it doesn't work. So how do we do this? Well, what about thinking like economists and having a balance sheet? And this one is for natural capital, but you can do this for all capitals. And of course, economists do it for money. Now we've got current assets, put it on the left here. So that's what we've got. We've got the liabilities. Now, if you take liabilities from assets, that will leave equity. That's what's left after you take liabilities from assets. Now, how would this work in terms of natural capital? Well, how much do we have, and how much is being employed in business? We could look at property, for example. Who owns forests? Who owns soils, fields, etc.? Who owns lakes, etc.? What's the business relationship between them? Is it ownership? Is it just a legal right because I'm a human being? I can use the recipients. How is that? So that's the assets that we have. As all human beings, we have access to this capital. Now, the liabilities come from the right of use and duty to prevent capital degradation. And there's also a liability, which would be the restoration of degraded capital. And that would be according to use rights. If I drive my car, put carbon dioxide into the air, is it included in my usage rights that someone else will take the carbon dioxide out, or is it up to me? In my role as citizen, it's quite an interesting question. Just that. Equity is what's left when you take away. That's to say, how does our natural capital look? Is it depleted? Is it full? Is it depleted in some areas? Now, in order to get into this, we'll try and make some kind of example. This is a very simple and simplified example. Let's just take a forest owner, right? So we've got someone owns forest. Now, the asset of that is the potential for fiber, timber, packaging, paper, and bioenergy. Maybe that person owns the forest, or they lease it and get the material from it. There's all very many possibilities there. However, we could also see the forest as being natural capital, that is part of the nation. Now, that is the whole ecosystem. In Sweden, they identify 30 services that come from the forest, whereof one of them is just fiber. When we go to liabilities, well, we can look at our forest owner and see, well, how much is in production and how much is mature. It might be that our forest owner has cut 50% of his forests and they're growing, and maybe 50% are more or less mature so that they can be cut, or it could be less than that. In Sweden, they cut something like 20% of what is mature per year. You can see how we get into systems dynamics with this already, about how much is in the stock and how much is being replenished by growth and how much is taken away. Depletion is how much is depleted. That's to say, of the forest ecosystem that we could expect with it being mature and fully developed. How is that? And then we go back to productive capabilities, the equity. So it's like what we have as a potential minus what we've got going. That's the productive, or minus what we've taken. That's the productive capability. And then you've got, in terms of equity, you've got the remaining biodiversity and services. We could have an example with that now. For example, well, 100% is always, it takes a percent, 100% is always potential. And then you've got, we said we've got 30 services, which are our assets. Let's say in use, we've got 75%. Now that would leave 25%, which we can cut. So 75% we've cut and is growing back. 25% is what we can use as forest owners. In terms of depletion, in Sweden, according to a recent report, only 10 of the ecosystem services are of a good status. So we've got 20 of the 30 are depleted. So our equity would be 10. Now this is starting to give us a basis for decent discussion, I hope. But there's some more things we need to add to this. Now this is a normative way of thinking. Remember, we want to get scientists in the room with economists, with authorities and civil society, and to have something that we can all discuss that isn't just a balance sheet from an economist, which no one understands, and many of us suspect that that the science or the methodology behind the economics isn't reliable. Now, the way normatives work is we say something like this, but if we want something, now wanting is that we value it, then a measure, and that's something that's scientific, should be at a certain level. Now, this is the way this works. It's politics would decide the value of it. It would be science-based to translate that want into a physical measure, understanding. Of course, we're talking about capital now, natural capital. The science should give us a measure, and then it should be, the science can give us a figure. So science is telling us what to measure based on the value that's coming from the politicians. This is what we mean as normative. This can give us a figure, which isn't an economic figure, and it would be the current status of our real capital, which would be the status of it now, over what it should be. And then we can give the value of the real capital that we want. So against, what it should be. We'll talk more about this. Now, if we want, for example, let's just say, if we want to limit global warming to climate stable temperatures, that's a political decision, even though it doesn't seem like it, then carbon dioxide levels in the atmosphere, now we're translating a stable climate to a scientific conclusion. And then the measure would be, we've been told it should be at net zero by 2050. This is an example of how to frame things. The important thing is that discussion becomes, if you want this, then we should do this. Of course, we have to have the discussion, do we want it? Do we value this? But the moment we valued it, then we should listen to scientists saying this is the way it should be. Normative helps us bring the conversation to an actionable, into the area of actionability. So to achieve the should be, and we're talking about the properties here of the real capital, then they should be at a certain level. Now, in terms of real capital, we're talking about our atmosphere, which is a shared resource. So the science and engineering would come from the properties, and the level it should be is also coming from science and engineering, as we're talking about what is possible. For example, to achieve net zero, the fossil fuel use, say, of the transport and energy system should be zero by 2045, which is what the Swedes have said. It's a reasonable goal. So to achieve, there should be is real capital and science and engineering. But where does the rest come in? Well, the real capacity change will require investment. And so the capacity change, we need to ask science and engineering and business into the room to look at what firms are possible to create that, how it's possible for firms to create that capacity change. Economics can bring together the investment required. Now that means that we're creating a discussion basis where we bring in the three aspects into the room, the industry, business, and economics, together with the social and political values and the environmental. Let's go back to our discussion about the forest. Now, if we were going to do to bring the forest back from its 20 depleted services, would probably require nature-based methods to be introduced. It would require a normative of 100% cover. At least this is proposed by some scientists. Now, this would create a liability on forest owners because they would, to comply with the rules, it would probably mean reduced extraction. It might not mean reduced profits for them. There's a big discussion going on, but let's just keep this high level, what it could mean. Depletion is uncovered. Depletion is about 20% in Sweden at this time. That's to say, I think at any one time we've got maybe 20% of the forest is actually forest no longer. It's actually clear felled. And as we said, the services were lost at 20. The equity, of course, is the remaining capability, and it's also the equity is the amount of cover at this time, and the 10 services that are still working very well. And again, this is where the question about investment comes in. What would be required? And we could talk a lot about this investment and how we put this investment against the will and the intention to restore capital. Let's give a summary here because we've covered a lot and I'm not sure that I've been 100% clear. Systems dynamics can be applied to real capital, and you're looking at the status of it, the parameters, its capacity and thresholds. And we talked about the 4 forms of real capital. One of them, which is built capital, is important in this dynamics equation because it determines a large proportion of the investment, and that's where the economics and ecology and the rest of it meet is in this investment, and also because it determines its environmental and social performance. Now, this assets liability equity approach clarifies and quantifies, or can do, the firm's effect on real capital, and especially natural capital, with its built capital. Even the ALE approach could be used to look at the total production system and its effect on nature and society in any given geographical area, or possibly even global. Now, a normative approach with this capital status produces a good and solid decision basis for the three areas of sustainability and the three areas of stakeholder: economic, social, and ecological. So that's all I had to say. I hope you enjoyed this, and please get back to me with your comments.